Hi everyone again, this is Manas. Good morning, good evening and good afternoon based on various locations across the globe. We're happy enough that we have got the participants throughout the entire globe to be a part of our this webinar. So what we'll do is after this meeting, we'll send you the entire recorded session. If in case somebody has missed any session in between or any voice in between, please don't hesitate. You'll receive the detailed recorded video on your emails. And secondly, in between, I might send you or at the end one feedback link where you please assist us in giving your feedback so that we can improve ourselves on a particular site, whatever the questions we will be asking. And meanwhile, let me introduce Mr. Vinay Kumar. So he will be the presenter and he will conduct the entire session. So Vinay, he is basically a researcher from IIT, and he has spent ample amount of time in the industry on the particular domain. Right now, I'll be handing over the entire session to Vinay from here onwards.
Thank you, Manas, for courteous introduction. Good morning, good evening, good afternoon, based on location you are in. So I am Vinay Kumar, as Manas said, and I'll be the presenter for this webinar. So this webinar, what we intend to do is give you a high-level overview of what machine learning is, give you a high-level overview of what we are going to cover during the course, and the major intention here is to clarify any doubts you might have onboarding to machine learning or artificial intelligence or any kind of doubt you have related to this. I would be happy to clarify. So these are the things that we are going to cover during this particular session. We will discuss what is machine learning. We'll discuss a very small puzzle. We will have a fun way of learning how actually machine learning works, or in general how learning happens through any machine. We'll also learn about type of learning, what are the different kind of problem which is associated with machine learning, and how do we particularly approach a particular problem to solve it via machine learning. We'll discuss some common tools like R, SAS, and there are plenty of tools available right now, and why we should go about Python and why it's a good way to start with Python. We'll discuss that how we build that, how we put that in production, how do we make sure everything is working fine the way it is supposed to be, and we'll end the discussion with bias variance trade-off that tells us that how we should be balancing the problem which happens mostly because of data. So machine learning is something which we experience every day, and it's a term which has been very fascinating to a lot of people. We see it, we hear it almost everywhere. So machine learning is something which is being used in e-commerce, it's being used in healthcare, it's being used across the domains to solve a lot of problems which we will be having a high-level view today. So to start with, when you go to a site like Amazon, you see that based on the item you are going to purchase or having a look at, you are recommended other products, which is like you are likely to buy along with the product you are having a look at. So that's the product or personalized recommendation that gets solved using machine learning in the domain of e-commerce. Another example will be Google search. So when you search a particular term, for example, machine learning, you see that there is a type ahead generator, that is, you are seeing what is or what has been searched previously along with that term. Another example would be, let's say you are comparing two things. You say cat versus dog, or you say day versus night. The moment you type day versus, you start seeing recommendations that with what is the other term with which it has been already compared. We were on this example wherein machine learning is being utilized by Google. And what Google is trying to do for tomorrow is, Google is a search engine right now for everyone, but tomorrow what Google is trying to do is build an individual recommender system That is, right now you see preference or see other options, recommendations based on what others have searched. But Google is trying to make a search engine at per individual. That is, they are collecting lots and lots of data about you, and tomorrow they are going to build a search engine which specifically works for you based on your data, your visit data on the past, your any kind of data which is collected on the Google server. That's where you see they're collecting a lot of data, because in machine learning, you need lots and lots of data to be able to understand what's happening and what can be done. When you see the Google News, this is what happens. All the Google News, there are plenty of pages with manual effort that cannot be sorted. So what happens, it automatically learns that where to put what news. For example, if there is news about South Korea, it goes into the world section or the category. If there is a news about Google buying another company, it should go into business. There is a news about Bollywood, possibly that should go into entertainment. So that can be learned from the keywords that is occurring across the pages or a particular web page. So instead of manually classifying it, we create a machine learning model which keep learning from the data, and tomorrow it can classify. One of the best example which we see every day is filtering of spam and ham. So I can go endlessly about discussing about the problems that machine learning solves. So may it be driverless car, security, robotics and automation. So there are plenty of examples which is being solved right now, and it's definitely a fascinating field. I guess there are a lot of people, a lot of attendees who have joined in from different domain. So this is just to give them a heads up in terms of what's being solved in which domain by using machine learning. So in those who are in marketing, maybe you have heard of these terms, predicting lifetime value. That is about predicting how much a new customer will spend over their entire lifetime with your website or maybe with your company. There is another thing called wallet share estimation. So for example, you have some money in your Google Wallet or maybe some local vendor like Paytm. So they try to predict that how do you share that money to buy something from the same company, that is you can also buy from the paytm.com, or you can use that wallet to buy product from another companies. So there is a kind of sharing which is happening between that company and other company using the wallet. So they try to estimate that how they try to know how you are sharing that. A lot of customers not satisfied with your culture, company, your services, your products are likely to go away. So people try to understand that how the customers are churning away from your services. So that's about churn prediction. So likewise, I think whichever domain you pick, right now you will find enough examples or enough use cases which is getting solved using machine learning. So in sales, we have deal prediction, revenue estimate, sales forecasting, and that list is a kind of endless list. So this is from customer support, human resource. Now people are applying HR analytics, wherein they can classify the resume and they can understand that. So when the people right now search with a keyword like Java, they are able to hit your document in maybe some portal. They basically send out a mail to you without checking that you were a Java resource, but right now you are working as a Python resource. So kind of testing the recency of your skill set is not done manually. So that is something can be taken care by using machine learning, and that's what happening in real time. I know a few of my friends who are working in that domain. So as we talked about machine learning, we went through certain use cases which is getting solved using machine learning. The most important thing here is data and the right question that you need to ask about the data. So how do you think about data when you are talking about machine learning. So this is a nice way to think that the data which you have been seeing in RDBMS are the structured data. So we can do machine learning using those data. Data like text, audio, image, and the combination of audio and image, that is video, is unstructured in nature. So almost always we can apply the machine learning algorithms very easily to the structured data because it is structured in nature and it requires very less amount of pre-processing in comparison to unstructured data. So structured data, you can apply a low amount of pre-processing and you are good to go and apply any machine learning algorithm. But if it is unstructured, like you talk to Siri, you talk to any personal assistant system. So when you are talking to the personal assistant system, what's happening at in the backend is your text, your voice is getting converted into text, and there is a search which is happening. Then finally there is a result coming from the backend, and that result is being thrown at you by converting it into from text to audio. So it's quite tough. It gets tougher when you start dealing with unstructured data. So the major task here for applying any machine learning algorithm, which we'll have a look at, is to be able to pre-process this data, to make it machine learnable or to make it consumable for those machine learning algorithms. And that is where you need to spend plenty of time. So everything in machine learning or data science or AI. So in our last webinar, we had this question that what is the difference between ML, data science, and AI? So AI is the artificial intelligence, which is parent of everything. Data science is a fancy term, and machine learning is something which comes under AI or data science. So there are a lot of other terms like NLP, that is related to text and is described as natural language processing. So there are a lot of fancy terms that right now that is being coined in this area, but basically they all mean the same. AI being the parent of those. So what happens when you look at the data, you start asking questions. So to give you an example, let's say you are working for your client and they happen to be in banking sector, and you have past data related to loan default, and it is saved in terms of soft copy. So what questions you can start asking is what's the age of people who have been defaulted, and possibly what's their income, and you can go on and start being inquisitive about data and try to understand what make them a defaulter. And tomorrow when you have fresh applications coming into the system, you can use those logics, use those learning, use those insights to decide whether to give loan or not. So one question here is, if I have the data, let's say in form of Excel, do I need machine learning algorithms to answer these questions? Like, what is the age of people who have been defaulted? I can just go to Excel and I can sort and filter, and I will know that, okay, these are the people having age so and so have been defaulted. So machine learning is not something which is applicable to answer these simplistic questions. Rather, machine learning captures the complex interaction which you might not be able to see easily, which requires some kind of mathematical rigor to understand what's happening among those columns, what's happening among those data. So let me check the chat window quickly. So when we talk about the industry, people also use the term analytics for ML or NLP. So the first question is, can I avoid this for my company? So what happens? Let's try to understand the scenario. And there are a lot of people who talk about singularity, that machine learning or artificial intelligence can surpass human intelligence. There are a lot of news, discussion, protest going around this, that people are going to lose job if you automate everything using machine learning or NLP. So I think machine learning or artificial intelligence is something not to cut those jobs, rather to augment human ability to automate few of the stuffs. And Why do we need to automate those? Let's try to understand from this simple example. Let's say there is a company A which believes in automation and they deliver in hours. And there is company B who believes not in automation, they believe in manual labor and they deliver in days. So let's say I give a amount of work to company B, they give me back the result in 5 days. And since it has been done by human, it is most likely to be very accurate. So take the example of this one, the loan defaulter data. So I want to process all the loan application that has come to my system, and I want to be as accurate as possible. But it's not always the requirement that I have to be 100% correct. So what happens with the company B? They start delivering, or they have been delivering in order of days, and slowly there is another company who started doing automation and started delivering in hours. So what will happen is client will become happy because with automation you have lesser response time, you can sell more, and you can sell your product to more and more clients. Because what happens in low default is it doesn't matter whom you give loan to, because you want to maximize the number of customers. So the more number of clients you have, the more revenue you will have. So slowly see that these clients who are getting a response in days now will be approached by these kind of companies like company A, and they will be given these options: low cost, low response time, and happy customers. So definitely these clients are going to go away from company B, and ultimately what will happen is company B is going to start losing those clients which were customer to the company B. And slowly they will lose the business, and they had this vision that they don't want to lose job, they don't want their people to lose the job. Ultimately the company might get shut down, and instead of saving those people, actually they end up losing all the jobs. Instead, I say company A is smarter because they change the nature of job. The job is not the redundant one, because redundant task is taken up by those automation. And one thing you will observe that with more and more automation, less and less human are there in your work. And with less human, you have less emotions to handle, less problems to handle, and less managers are required to handle those people, because everything is managed on the server. Yeah, Sunil, you are correct. So Sunil says basically low skilled workers will lose job, and there will be high demand for skilled workers. So Sunil, what you're saying is correct. To amend that, I would say people have to be very competitive right now. They need to change the nature of job. It's not the thing that they are going to lose the job. So people who are ready to accept, and I appreciate the audience today who has been jumping into this, have heard from their friends, family, or somewhere, and they have started exploring what is machine learning. And definitely, you need to change the nature of your job. Otherwise, there is a high chance that your company might be the company B, and God knows what happens. Okay. So I hope we are clear about why we cannot avoid analytics or machine learning or any kind of automation right now. So just to give you a context about what is machine learning, let's start with what is not machine learning. So we have some data, as you might have heard about big data and handling a lot of data and gaining insight from data. So traditionally what used to happen, we used to define those functions. We used to write a function like add two numbers, maybe multiply five numbers, and then we used to feed some data to the function, and we used to get the output. An example will be, let's say I have this data wherein I want to predict, or I want to calculate the house pricing based on the area in square foot and the parking area cost. So the formula is simple: area into 400 plus parking cost is the output that we want. So definitely when we have these functions known from simplistic data like this, we can code that function and we can deploy it and we can have the output. But that's not the case right now. We have a very diverse set of data, diverse set of audience, diverse set of customers, which is not making the job easy because these data are very much diversified. Capturing such formula from such data set is not an easy thing. So what we do instead is apply machine learning. And what it does, instead of we coding this formula, we'll let the machine learning algorithm take this data as an input and it will automatically learn this function. Now, I know it might be a bit confusing to you as it was to me some 6 years back, that how possibly machine can learn a function from a data? How is it possible even? So nothing to worry, I've got you covered in the next couple of slides. So we'll just have a fun puzzle to understand that how possibly we can make a formula. So with data, we can learn this function using some machine learning algorithms. And then tomorrow, what I do, the same thing. I deploy that function, which is coded by machine learning algorithm, not by us. And we feed the traditional input, whatever we had, and we get the same output. Making sense so far? Any questions audience have till now? Okay. So as I said, you will be having some confusion that how is it possible? How data can help us trigger learning, or how data can help us learn a function. So let's play a puzzle here. So I want more attention from the audience right now because I want answers from you in the next slide. So let's say there is a man who wanted to enter a club, but there is a security guard who lets you into the club only if you answer his questions. But let's say I am that thief who is standing behind a tree and I'm trying to learn the pattern that how possibly people enter into the club without showing the ID card. So the first man goes and the watchman says 12 and the member replies 6. So possibly I have made certain logic. Okay, if he says 12, the person replied 6 and he is him. The next member goes, the watchman says 6 and the member replies 3. So again, I got another data point. I somehow have made some logic in my mind. And I think that's what is happening with you right now. So here is the question that I want you to type in the answer for. So you being the person or I being the person standing behind the tree now approach the watchman with confidence that I can answer his questions. And the man came and the watchman said 8 and the member replies, or definitely you will reply based on your logic 4. But the watchman did not open the door. So possibly what's wrong? So my question here is, let's say being a watchman, I gave you the number 6. So what's your answer? Can you type in? Or can you type in what's the answer or what's possibly wrong? Okay, Nasir says 3. Oh, one person has got it correct. Okay. Okay, so I know based on your mental model, so can you observe your mind what's happening right now? When I asked you to solve this puzzle, all you did is you consumed this data to make a mathematical model in your mind, right? And most of us have made this function or logic or model inside our mind saying that if it is 12 divided by 2 is 6. If it is 6 divided by 3 is divided by 2 is 3. But that's not the model. Because if that would have been the case, 8 divided by 4 should be correct answer, but that's not the case. So possibly what went wrong? So here is the answer, that when you saw 12, you imagined the number 1, 2 and you divided by 2. Rather, the logic is to count the number of words. So 12 number of characters is 6. 6 number of characters 3. 10 number of character 3, 5 number of character is 4. So that was the logic. So why I am showing you this example or the puzzle is to convince you and to establish followings that yes, learning can happen with data. Second thing, when I gave you these mini data, that is I gave you 2 records wherein input was 12, output was 6, input was 6, output was 3. You made a logic which perfectly worked for these 2 data points. But when I gave you another data point, you have another logic because it failed. With input 8, output 4, the match is incorrect. So from this puzzle, what we can establish is yes, learning can happen with data. And the more and more data point I give you, you are going to refine your logic and you are going to go as close as possible to the actual logic which should be working. And sometimes you were imagining in terms of 12 or number 6 did not help you solve the problem. So what you need to do even in machine learning is you need to transform the data. You need to see it differently so that you can start forming a logic, because when we are seeing a machine learning data, we are seeing a real world data. We are seeing diverse data. We are seeing data which is contributed by people who have different ways of expressing the same thing. So you need to transform the data. You need to have more and more data to learn the logic. And in machine learning, what we did here is nothing but the same thing, right? We had this input, output, input, output. We had to learn this logic, which you certainly had made in your mind. And then we use that logic to answer the next question. So have I been able to convince you on this 3 points that yes, learning can happen with data. More data is much better because we have better learning. To give you a better understanding or to be able to relate with you, I think almost all of us have been students somewhere and we studied throughout our semester. So what was happening throughout the semester is we were getting trained. And our teachers used to say, don't mug up, don't learn the answer to the question, rather solve more and more questions to learn the logic. And I think some of us used to mug up the answers and we used to terribly fail in our exams. So when we used to give those exams, what we were going through is testing. And the same thing happens in machine learning. We are given some data through wherein we have the questions and we also have the answers. But yes, Ankur, what you wanted to see in the previous slide? You mean this slide, Ankur? Okay, you have any questions around this, Ankur? Ankur, I think I'll take your question towards last. If you have any. Okay, you're just figuring the logic I have told. Okay. So it's something I put forward the analogy that I had, we had kind of created here. So it's a kind of analogy which helps us understand that machine learning is, not something very much out of the box, rather it's something which is happening across us. So when we
sorry Vinay, so Nasir has also a question here.
Okay.
He's asking, this means ML is a constant job. With each data point, it should refine itself.
Right. So that's a great question, Nasir. I think with each data point, it does have to refine itself. But when we look at the data, sometimes there are anomalies. There are bad data. For example, somewhere the height is entered as 60 feet for a human being, which is a bad data to any algorithm. So in those cases, yes, with right data, it should refine itself. With wrong data, it should avoid to learn those wrong inputs, because from that it is learning the wrong logic. That's how it works. So when you are giving those exams and when you are giving those tests during the semester, you are actually getting tested on logic and not on how you mug up those answers. So the clue here is don't mug up, don't learn the data, rather learn from the data, learn the logic, because if learning happens in terms of answers, you are going to suffer from something called overfitting in machine learning. That is, you are overfitting your logic to learn everything or learn the data itself. And that's how in ML model we need to, these are the problems in ML model also. When we give the data, if the algorithm is not correct, it sometimes tries to mug up the answers, or instead of forming the logic, it might mug up some of the insights which is there inside the rows. So we have to make sure, we have to check using certain methods, and we have to make sure that it has not mugged up those. And we will discuss that in today's presentation as well, something called cross validation. So till now I have been trying to convince you on what is learning, how learning happens in our mind, and possibly how learning can happen in machine learning. So let's take a look at it more formally. So as I said, there are multiple columns. Let's say loan defaulter or in house prediction. This is the final price that I want to predict. And then there are a lot of variables which decide the price, like is it window, is it sea facing, is it how many number of rooms are there, how many bedrooms, how many washrooms, is there any furnishing done. So all those variables which we take into account to decide the final price or whether the person will buy it or not are in machine learning world called features. And what machine learning has to learn is how these features interact, or how these data interact among each other to establish a function, and how can I use that function to predict the outcome. So what machine learning is doing is establishing the relationship between these features. And for human, it is very tough to understand the complex interaction which goes behind the scene. So machine learning will learn these interactions, code it in a form of formula, and it will be inside the model, machine learning model. And we can use that to give a new data point and predict the outcome using those models. So as we saw, human learns from observation during the solving that puzzle. So same way, machine learns from the data or the different observations. So it's a set of computer programs that automatically learn from data, and as you keep on more and more data, it will improve based on experience it will have from more and more data which is getting added to it. So we can say we give a data, machine learning learns a relationship from the data. In human case, we say we have observation, we learn, and we have knowledge or experience from the data. So we can conclude machine learning is similar to human learning. And I saw a question in between related to neural network. I think this is the right time to answer that. So Nasir says, is ML the same kind of AI as neural network? So as I said, every research which happens somewhere, it is derived from human experience. It's just about reverse engineering the things and being able to use or utilize that to automate the stuffs. So machine learning is quite similar to human learning. And when you talk about neural network, it is doing nothing but trying to replicate the behavior which is happening inside our brain, trying to utilize how neurons take decision inside the human brain. So the second confusion a lot of people have who try to get on board into machine learning world is, I see my friend saying that you need to learn statistics. There is other set of friends who says you need to learn programming. There are other coders who says mathematics. So I'm like confused. What is the requirement? What do I need to learn? Where do I need to start? And there has been a lot of confusion around from people who don't know where to start. So I would say machine learning does require multiple skills. You need to learn a bit of stats, a bit of mathematics, programming, problem solving, and generally you see on the internet people put image something like this, which makes it even more confusing. So I will show you the next slide. So we have found out this one by Swami Chandrasekaran, and this is a better roadmap. And when you see this, try to map with this particular figure. So here we have mathematics, statistics, problem solving, artificial intelligence, big data. Try to identify those elements here. So how do you start? You start by learning matrix, linear algebra, bit of data frame series, and then statistics. So from 1 till 5 is something kind of compulsory for almost all the data scientists. Maybe you can stop at 4 if you want to only work with structured data that is there in RDBMS. Nothing is going to harm you if you stop it here, not here. You need to at least come till you need to at least complete till here. And if you want to also learn about how to handle unstructured data, you need to complete till 5. So this is a very nice way or very nice roadmap to understand what all you need to learn to be a data scientist or machine learning engineer. And if you specifically want to create a niche and you want to become an NLP engineer, then maybe you need to learn this part. As of now, or for any data scientist, I don't think big data is a compulsory thing. A lot of companies work on big data, and a lot of confusions are around that it's a must to have big data skills on your resume to get a job in data science. And I am totally against that opinion because that's not required. I have been working as a data science. I don't know, I do know about these things, but I have never used it. So I can confirm you that this part, Hadoop, big data, you can add on tomorrow, but it's not a compulsory thing. And that is why the Mr. Swami Chandrasekaran has also kind of put it separately. So these things, it's all add on. You want to add tomorrow after completing these things, you can always add on. So I think people might have questions around this. Any questions you have so far? Okay, so to more formally discuss that how machines learn, what are common methods through which machine learning happens. So these are the major kind of categories: supervised learning and unsupervised learning. If you check Wikipedia, I think there are a lot of other different ways described, like deep learning. I think most of us have heard about this. So deep learning again is something irrelevant to this, but that's the next level of thing. So unless you spend like plenty amount of time, if you are starting right now, at least you should be spending like an year or solving at least 5 to 10 use cases using simplistic machine learning algorithms. And then when you think that you can go unsupervised, then you can possibly use deep learning. But as of now, I see a lot of people jumping into deep learning, which is not a great idea.
Sorry, Vinay, please hold on. There is a question from Nasir again. Is knowing Python required for this presentation?
Yes, a bit of Python is required, but what we have done in the course, we have few introduction related to Python. That is just to give you enough time. If you're not aware with Python, you can take that time to utilize. And these courses are happening over the weekend. So you have enough time between the courses to cover up things which you don't know. So because in the course, we have both the things, the theories as well as the coding session or the practical session along with the projects. So you will have plenty of time. And as far as Python is concerned, it's very easy to code in Python, although tough to read. So that's how it is. So it's very easy to learn Python and be able to code in Python. Okay, so coming back to most common machine learning methods, which are supervised, unsupervised, semi-supervised, and reinforced. Okay, so let's discuss about supervised learning. So in our course, we are mostly going to deal with supervised and unsupervised, and semi-supervised and reinforcement is something which is not in the scope of this course, and also not very much required when you start your career as a data scientist. So most of the problems are generally solved using these. So we'll still would highlight during this session that what are those. Supervised learning, how it happens. Let's say we have some historical data, as I said, and I want to learn a function from it, or we call function the model or the function or the logic. We can call these all are synonymous terms. So just imagine that you have a credit card department who has collected the historical data for the loan defaulters. So here you see what are the ages of those people. So here you have the output. Have they defaulted? Yes. And the other option is no. So these are the data which is particular to a particular defaulter or the people who are not defaulted. So what machine learning has to do here is to learn this model. And in supervised learning, what happens? We have the output known. As I said, you learn throughout your semester. Your instructor is going to give you a problem. He's also going to solve it for you. That means you have the questions or you have the data and you also have the answer. So here in machine learning, you have the output known. So what happens? I will give you this much of data, right? Let's say here we have for 8 number of rows. So when I'm training you, I'll give you 6 rows of data and I'll tell you the answer as well. But when I'm testing you, I'm going to test you on these 2 records and I won't give you the answer. You have to tell me the answer, and since it is known to me, I will go and compare whether your answer is correct or not, and then we can compare the accuracies. So this is what happens here. Once we have learned the model out of this, we deploy it and then that predicts the output. So defaulter column is not given when the prediction is happening, and the model has to predict it, and then we will use that prediction for our business purpose. In supervised learning, what happens? We have the output level or the answers known. We use that to train a model or to learn a function, and then we use that for the prediction. Whereas, so in supervised learning, you might have heard of these terms as you are interested into machine learning. So we use regression. That is most of the problem which is there in house price prediction. So when we have to predict yes or no, then it's only about predicting 2 classes, yes or no. But when we have to predict the continuous value, that is predicting the price of house based on another feature, that becomes a regression problem. When you have only 2 outputs, again yes or no, we use logistic regression. There is something called interpretability versus complexity. So when you apply any sort of algorithm related to machine learning, there is a trade-off between both. So some machine learning algorithms are very interpretable. That is, it will let you see what is the logic that has been formed, and almost you will have idea on okay, what is the logic that it has learned. But in some of the algorithms which tend to be higher on accuracy side, are learning very complex interaction between the columns, and those are something which you can't understand just by looking at what is the model that has been learned. So decision tree is one such algorithm which is very simplistic. If you want to look at what is the rule set that has been formed, in form of a tree, it shows you very nicely that okay, this is how I am deciding. The first thing I am checking is the income of the person. Second level, I am checking what is the age of that person. So this algorithm gives you an output or the model which is highly interpretable. Let's say you are the individual decision maker. So always consensus is better than a single decision maker. So instead of making one decision tree, we can make a forest out of it, and we can randomize the data to learn a better model or to form a better logic. Likewise, there are algorithms like bagging, boosting, support vector machine, k-nearest neighbor, name base. So these are the algorithms which is used when you have some data like this, wherein you know the output and you can train the model with the output level present in the data. But what happens when we don't have the output level known? We don't know what is the output. Then we apply something called unsupervised learning. So possibly you might be thinking, what's the utility when we don't know the output or we don't know the output level? In some cases, we don't want to know about the individual. Rather, we want to learn about a class, or we want to know how to cluster these users. So let's say I have group, I have these data and I want to cluster it instead of being able to know individual response or individual output. I want to just cluster it. Then we use something called unsupervised learning. And possibly how you can cluster it, just imagine that there is a facility center, or there are facility centers that you need to open in a particular city, and you have a money constraint. You want to open only two facility center in the complete city. For example, let's say you are the CEO of XYZ company and you want to provide service to people who are residing in San Francisco, and you want to open only two service center. So what you would like that you open service center at two places, and you should be able to serve as many customers as possible with those two centers. So what you will do, you will put the center in such a manner in the map so that your total distance with all those houses become minimum. That is, basically, the complete city is clustered into two clusters, and then you put yourself or your service center at the center of those. So I'm just giving you a high level view that how in real world that this is utilizable and useful. So almost all the facility center, almost all the go downs, almost all the service center, facility center are kind of designed using these algorithms. So what we intend to do here is to cluster, not to know the individual responses. So here we can cluster it into group 1, group 2, group 3, and these entities or these data which is in one group are very close to each other. Just see 18, 17, 16. So if you calculate the distance among these are very close to each other. That's why it's in one cluster. The second cluster, you see it's 15, 14, 13, which is very nearby. So we can use one of the columns as a basis to find distance among those, and then we can use that distance to cluster it. And that's the basis for unsupervised learning. And possibly how do we do that? Using one of these algorithms. K-means, hierarchical clustering, TB-scan. In credit card data, we use something called anomaly detection. We use hidden mapper model. And there is another thing called generative adversarial network, which gets utilized by e-commerce companies right now. So you might have experienced this. You receive an order for a cloth which looked something different but is actually something different. So what happens when they put the image on the site? They kind of use something called generative adversarial network to take one kind of pattern as an input and form another pattern which actually does not exist. And this is being highly utilized in e-commerce industry right now. So I'll take up the questions now. So Dev Pratima says, I want to parse a pic where some letters and human pic is there in access card, and I want to use machine learning process to read the details. So how do I do this? So Dev Pratima, as we were discussing about unstructured data, we had something called image processing. So you apply, starting from, some people apply OCR. Using OCR, they are able to extract optical characters. But since you also have human pic, you might need to apply image processing. Using image processing, you can extract all the data like human pictures or your letters. I hope that answers your question, Dev Pratima. And we can discuss in detail one-on-one for use case. Okay, thanks, Dev Pratima. Okay, so there is, I would say, third category called semi-supervised, wherein you don't have. So let me tell you, this data is very important. A lot of companies, they have a lot of data, but it is not having the output level. And getting these quality data is very tough. So if you have lesser amount of data wherein you know the output, you can use something like semi-supervised learning. And in that, people apply algorithms like active learning, generative models, graph-based model, something called co-training to be able to learn from those data. So this again, is something which is not in the scope of this course, but just to give you a high-level overview, that it is about using lesser amount of data, which is having the output level known, and still be able to build the model. For example, if you see web classification, some of the web page would be classified manually, but tomorrow, at the rate in which the web pages are coming up, you cannot manually go and have the output for all the classes, right? You cannot put, so today let's say there are 1 lakh pages which has come up on the web servers. You cannot go and classify those or label those saying, okay, this is this particular web page, this belongs to this category. Same is the case with Google News. Initially, you start with some data, you learn some model, and then tomorrow your model has to be very active, and you need to configure in such a manner that tomorrow, even if you don't have the output levels or the answers known to you, you should be still able to utilize the model which you learn using lesser amount of data and still be able to solve your purpose. So that's what happens in semi-supervised learning. So machine learning problem, we can see that, let's say you want to predict the house, and you have a lot of columns, as I described here. During this, you have a lot of columns and you want to predict the price. So we already know we have to apply regression because we want to predict a continuous value instead of predicting yes or no. So you can predict a value, that is predicting a continuous value. You can predict event or outcome. For example, filtering spam or ham. So when you get inside your Google email, you see that the mails are getting automatically classified as spam or ham. So that's something wherein you can apply something like logistic regression, because the output has only 2 levels, spam or ham. There are other classes of problem called multi-class or multi-level problem. So when you look at your Gmail ID, you see that there are 5 categories, predefined categories, and possibly you cannot add the 6th category because you won't be able to provide the training data for that. And that's why Google has limited it to only 5 categories. So you have primary, social, forum, and what it does over time, it learns that, okay, these mail having these keywords are possibly an advertisement, so it should go under promotion. So you can also train that. What you can do, you can select some of the mails and you can drag and drop that into different category if you think it has been misclassified. So that is where when you have to predict outcome, you can use machine learning here. This is very interesting, market basket analysis, which almost all the stores, bigger stores like Walmart, Amazon are using right now. When you go to a store, they try to see placing which product at what place makes it sell. Second, they want to know what are the products which are being bought together. So if somebody has bought milk, they have also bought egg. So they can check in your bill, they can find an association, they can find a frequency that how many times people have bought milk and they have also bought egg. And tomorrow they will place milk counter near the egg counter so that there is a high possibility of things getting sold together and they make better revenue. As I said, clustering. So if you have web pages, there are certain patterns you can look and you can cluster those. So these are just to highlight. So there are like tons of business use cases that are being solved, but just to highlight, to give you a high level overview, these are some of the problems which can be solved using machine learning. So this course is using Python. So when we did our research to understand R, SAS and Python, the popularity, you see for data scientists, Python is quite popular. And I'll tell you the reason that R is something which is good for business analyst people who just want to understand the model and they don't have the headache of deploying it in the actual server. So those people who want to learn just the logic, how does this data classification will happen, but they don't want to deploy it in the real-time environment, I think R is a suitable tool. But why not use Python, which let you do everything which you can achieve in R? Also, you can deploy it. You can deploy it in AWS, you can deploy it in Azure, you can deploy it in any cloud environment. And it's very easy to do it with Python. If you see the R libraries, it is basically following up with Python libraries. So whatever libraries you see in R, most of them are coming or being inspired by Python. So Python also has a very large community. We see a lot of conferences happening related to Python like PyData, PyCon. So there is a very strong community which foster the quick and easy development of Python related libraries like Scikit. You have tons of libraries which you can search about. Okay, so I think here we have what we have understood till now is what is learning, how possibly machines can learn, what is machine learning model, what are the different type of model, but most important thing which a lot of people miss when they just try to jump onto algorithms without understanding the whole picture of it. So this is the complete picture that when you become a data scientist or you start working in machine learning area, so you need to take care of all these things, and that is where you require all those knowledge of statistics or mathematics. So what you do, we want to solve a business problem, and that's the need wherein we want to apply this machine learning to gain insight and to be able to use those insights. So first of all, you need to very well define your problem. Let's say you have all the data for your e-commerce company, then you need to understand what problem you want to solve using that data. For example, in loan data, you want to understand who are the loan defaulters. So you need to identify your data needs and you need to define the problem that, okay, this is what I want to solve and this is the problem that I want insight about from a particular data set we have. Sometimes, as I said, everything in data science starts with the problem, not with the data. So you have a problem that you want to solve, you start collecting data about it. If you have data about it already, or the client is saying that, I have this data, I want you to solve this problem. So that's like very good condition. But most of the cases, what happens? You don't have the data, the quality data. So you define the problem. I want to check who are the loan defaulters. What are the attributes of those people who default after taking loan? They are not able to repay. So that's the problem. So I collect all the data from the company's server, and definitely I need to collect only those data which might help me solve this problem, because access wise also you won't be given all the data access. So you just collect data which is necessary for this analysis, and then to be able to feed it or to be able to build a machine learning model, you cannot straight away jump into applying it. As I said, there might be some pre-processing which is required. So in our puzzle we saw we needed to transform the data to be able to extract the logic. Some outliers might be there. For example, somewhere height is mentioned in some of the column and the height for human is mentioned as 60 feet. So definitely that's an outlier. We don't want that data because that's not the right data. And how it get introduced might be mistyped by somebody, or might be it's coming from somewhere which is not helping us understand the customer attribute better. So these are classified as outliers and you need to remove those, or you need to find a way to handle that particular record. So for example, if height is 60 feet, you may like to remove the complete record, or you may remove that height and just put an average height of human being. That should also work. There might be some missing values. Some of the columns might not have data for particular row. Then what you can do, you can again put the average values. There are a lot of ways in which you can calculate those values and you can complete your data. There might be some negative values. So again, based on your domain, you might accept it, or you might have to take care of your negative values which might be in data. So we start with the problem, we collect specific data for that problem, we do pre-processing, we make sure the data is complete and this can be used for learning, and then we start building the model. So mark my words, we don't build the model straight away, we start building the models. So we build the model, then we see the result, we test it, validate it, we see that okay, the accuracy is not good, we again go back to seeing the data, am I feeding the right data or not? So this happens iteratively. We pre-process it, build the model, pre-process it, build the model. If accuracy is coming correct, then finally we validate the model. We analyze that model is correct or not, and finally that model is deployed to give you the final recommendation. So that's the life cycle of machine learning model. You start with the problem, you collect the data to solve the problem, pre-process it, feed it to the model, feed it to the algorithms to create the model. Whatever model has been built, you validate it, and then finally you put it in the production environment to generate you the recommendations. Okay. So I have a doubt from Sunil. So as per current and future need, which one is better, R, SAS or Python? So as I have already explained, Sunil, that Python is something which is very futuristic because not only it has been building from the past, if you go and check out the number of libraries it has, it definitely beats all other competitor in the market because of this strong community, I guess, because there are a lot of people involved, keep developing something new, keep contributing to these open source machine learning algorithms. So Python is something which is something going to be make you a better person in terms of machine learning engineer or data scientist if you want to learn more about this. A lot of people are also applying Java, but again, Java is something wherein you need a very real-time results. But there are very few libraries in Java which can help you scale up as you start, applying more and more machine learning algorithms or machine learning applications. You start building more and more machine learning applications. So I hope Sunil, I was able to answer your question. Okay, thanks Sunil. So as I said, here we want to build a machine learning model. So these are the steps that you need to go through. So we'll quickly highlight what happens actually in the problem definition, data collection, cleaning, model building, model validation, and how do we finally deploy it in the cloud. So when you define the problem, you need to start questioning in this manner. So who is causing the problem? What is the problem we are trying to solve? Who is the person causing the problem? Who is the agent? What is the environment? Where does this problem occur from? So all of the questions might not be relevant to all of the domain, but this is how you start thinking: who, what, where, when, why, and how. So you need to be very deep in terms of understanding the domain, understanding the problem, and iteratively define your problem very well, because it requires a lot of rigorous exercise to explore the data to understand your problem. And that's where we call it exploratory data analysis. So the second step was, once we have defined the problem, we want to collect the data, the right data to build the model. So data, again, what happens some of the time, for example, when you collect data, you don't have access to all the data. So what you do, you collect the representative sample of it. I think some might not be very aware of statistics here. So just to give you an example, why do we need to collect sample? Because all of the time we cannot collect the complete data or the population. A simple example will be blood sample. You cannot, drain out a person for all his bloods. So you just collect a sample, which is the representative, and then you use that to analyze and be able to tell about the population. So in the blood sample, they take your blood sample and they tell you what's happening with your blood throughout the complete body. So that's how it happens. You collect the data sample and you infer about the population. Okay, so these are few things which we'll be covering in the course, that how do we do sampling, how do we actually make use of statistics or sampling to collect the right data to answer the right question. So these are a few sampling techniques that you define the population of interest. For example, let's say you want to calculate the height of people who are at your university or at your company. So you don't go and ask everybody to gather around a lawn. Rather, you just take a representative sample. You just start calling few people, and maybe you collect 50 employees, and you take the height of there, and then you do a lot of other analysis, which is part of statistics, to be able to say that okay, this is a representative sample, and possibly this is the average height of people in our company. Then, as I said, you need to correct the data, you need to make it complete, you need to remove or keep the negative value based on your domain requirement. You need to treat those missing values, remove those outliers, which is not real representation. You need to handle those missing values. If somewhere data is missing, you can make use of these techniques to fill in those data point or fill in those row column cross section. For example, height of a person is missing. Maybe you can assume that for this demography, the height is 5.5. You can just put it. So during the project we saw, we need to sometimes transform the data, because sometimes to make it easier, we already have transformed while capturing it. So you need to kind of reverse engineer, or maybe you need to transform it to make better sense out of it. These are few techniques which we'll be discussing in detail in the course. Okay, so as I said, so we are at the model validation stage. Let me just show you this part. So we covered till now how to define a problem, how to think about defining a problem, how to collect data or the representative sample, how do we clean and make the data which we can feed to the algorithm. Now we are at the stage that how do we, so about algorithms we have already discussed that how do we build model or how learning happens. So now we are at this stage that how do we possibly validate that whatever, I think that got closed, sorry, just let me open it. Okay, once we have built the model, what we do, we validate the model. That is, as I said, during your semester you are getting trained on 70%, and during your semester exam you get tested on few of the questions. So that's how it happens in machine learning as well. We train on some data, we let you know the output, and the machine learning algorithm has to learn the logic. And then for test data, we don't let the algorithm know the output, rather we want the model to predict the output, and then we compare with the actual answers that help us decide whether the model that has been built is correct or not. So how do we do that? We can think in this way. So we do it over multiple iterations. So first iteration, let's say this is my first row, second row, third row, fourth row, fifth row. Likewise, we have nth row. So what I do, first 5 rows I use as testing data, wherein I don't give the output, and I use these rows as my training data. Next iteration, I use these as my training data, and the one which is coming under this box, use these rows as test data. And likewise, over iterations, we validate the model, and since we are crossing over different rows, this is called cross validation. So we cross validate and make sure that there is no overfitting, there is no mugging up about the data, rather it is learning the right logic from the data. And why it is required? Because sometimes we might not have a balanced data. So let's say we have a data, we sort it on the basis of age, and then we give it to the data scientist, and the data scientist, what happens, he takes up top these many rows for testing or for training, and then he tests on the last few rows which is having a very unbalanced kind of data. So to remove all those effects of unbalancing or any kind of uncertainty, we validate it and make sure that we are testing and training, and we are making sure that it has learned the right logic from the right data. So there are some, definitely when we do this cross validation, there are some maths involved through which we can make sure that whatever model has been, if model evaluation has been done, we can use some mathematics to see whether it has correctly built the model or not. So there are a few things called true positive, false negative, false positive, and true negative. So these are the things which we'll cover in the course. Just to give you a high level overview, what are these? So let's say there is a thief out there, or there is a murderer out there, and instead of catching the thief, police catches the person who is not thief. So what happened there is you end up catching the wrong person for wrong acquisition. So actually what you did is called false positive. And then that thief is out there in the market. So because you were not able to capture that thief, that's called false negative. That is, when you commit some kind of error, it's called either false positive or false negative. But when you don't commit the error, then it's called either true positive or true negative. So we'll have enough example during our course to understand these things in detail. So as I said, we have built the model. Now we want to deploy it. So possibly how that deployment happens. So we have the model, which is, you can just understand that that's like a program or an API. We just deploy it in the cloud. And if you want to make it scalable, you deploy it in this fashion, that you have it in model, you have it in cloud, and then you have configured using load balancer. So this is something which is, a super production level, not just production level. You want it to be scalable, then this is how ultimately it looks like. You want to deploy only on a single server, you are free to do that. You just deploy it in one single server, and there is no load balancer requirement. You just call from the client. You call the API pings the model, give you the output, you just return it in form of JSON or whatever intermediate format you want. Okay, Hina says, do we get to see any code? So Hina, the idea of this webinar is to give you a high level overview of the course that what we are going to learn. So to keep it simple, we don't have any code right now, but during the course, for each and every algorithm we are going to have a look at, we'll have ample amount of mathematical background. We'll cover the theories, then we'll make sure that you're understanding the theory. Then we'll have Python code. Then we'll be giving assignment for each and every topic we cover, so that we make sure that you're learning. And at the end, there is also a project which you need to complete to make sure, and that will be evaluated to make sure that the learning has been transferred properly and you have learned it. But for this presentation, no, we don't have any code to show. Dev Pratima, I think you have a very particular question related to blob or clob. I think we can discuss offline because might not make sense for all. X-ray images. Any other questions? Okay, so if no questions, I'll proceed. So what happens is there is a problem of simultaneously minimizing two sources of error, that is bias and variance. So in bias, what happens? When we are learning something as a human, we have a tendency to get biased towards something. And when we get biased towards something, what happens? We end up capturing this variance. So at the same time, you cannot be biased or you cannot capture all the variance. So bias is about being biased about particular data, that is towards being on the side of overfitting, and variance means you are capturing all the variation which is present in the data. So this happens a lot of time in machine learning, that it might overfit or it might capture a lot more variation that we actually want to capture. So this is something which we can handle in the machine learning using something called cross-validation, which we already looked. We can improve the bias variance trade-off if we have more data, but unfortunately that's not the case. But if still you can add on more data, that is going to lower that bias variance trade-off. We use another technique called regularization, which is about not depending on all the columns completely. That is, what we do, let's say we have 5 columns, x1, x2, x3, x4, x5. instead of saying y equals to m1 x1 m2 x2 m3 x3, we take a subset of that. That is, we give a weightage to a particular column. So we use something called regularization technique to avoid this. So we are going to discuss that in more detail during the course, because I require a bit of mathematical background. So with that, this is what we have learned today. What is machine learning, how possibly learning can happen, and how it is, not something unnatural which is already happening in our mind. The type of different machine learning algorithms, the problems associated with it, and how possibly we can think about building and being able to deploy it and being able to validate it completely. So with that, I am ready to take more questions if you have. And I think I'm done with my presentation. Yeah, as I said, there will be a lot of algorithm that we are going to cover here. And these are the tentative list of projects which we are going to give you as an assignment, and we make sure that you are solving and learning each and every algorithm. So let me tell you this, in machine learning, when you are learning the algorithms, there are hardly 15 to 20 algorithms which you need to know. But trust me on this, learning those algorithms without use cases are not going to make it permanent for you. You learn an algorithm, you understand it completely, but unless you solve a use case, that's not going to make those algorithm clear to you. So that's where we have use cases and project across all the algorithms. Okay, so I'm looking forward to seeing the course, and I'll be taking the questions now.
Yeah, Vinay, there is a question from Ankur. He had some. He was asking about some queries related to AI.
Okay.
So he was just asking, like, are we covering any AI related doubts in this course?
Yeah, so Ankur, as I said, AI is the parent under which any kind of processing which you do with text or you do with relational database or any data which is unstructured, everything comes under AI. So AI is the parent term which is mostly used by researchers. For industry, the same AI becomes analytics. So yes, what we are learning is under AI only. So I'll quickly show you the course that is related to this webinar. So you need to head on to NearLearn.com, and there you see this course under AI and machine learning. There is machine learning with Python. So this is the specific course that we are talking about, or we are having a webinar for. So here you see the schedule, the prerequisites, the curriculum, which is detailed out here. And we will keep it flexible. If there is something which you don't understand, we are going to add it here. But as of now, as per our research, this is what you need to know as a package for machine learning. Okay, any other questions I might help you with today? Any other doubts you might have heard from your friend that, okay, this is the area to enter. So yeah, Ankur, the recording will be shared with you. Okay, Akshay says, how is data science different than machine learning? So any problem wherein you apply artificial intelligence. So let me tell you about this, where this term came from. So see, when we say that we have human intelligence, right? And then we want to apply artificial intelligence. So what is the need? Just take an example that government is trying to take a feedback related to any particular aspect. For example, let's say they are collecting data for smart cities. So how do they be responsive? How do they make sure that they're able to reply or they're able to understand the comments within a limited period of time? So now they, with huge amount of data, there is a need to be able to solve the problem as quickly as possible, although we may have to compromise on accuracy. So what happens, instead of using human intelligence, which is not very scalable because you need to hire a lot of people within a short span of time, but scaling those machines or scaling those intelligence, which is artificial in nature, it's very easy. So data science is the parent, I would say, data science or analytics. Since we are talking about the science which is relevant to data, it's called data science. So artificial intelligence is something used by researchers. Data science, analytics, all are synonymous, being used by people in industry. Does that answer your question, Akshay? Okay, Ankur says, can you explain it again? The data science thing? Okay, so I was saying that with human intelligence, scalability is something which you cannot have, because hiring people within a short span of time or hiring those many people will cost you a lot. And after hiring, you cannot, just fire people saying that work is done. But definitely, when you have artificial intelligence, you can spin up as many servers as you want. Once the work is done, you can close it. So by that, you are actually renting the artificial intelligence. You are making your solutions, or you're taking out your solution, and then you're making sure that the cost is less. So with artificial intelligence, you have lesser cost that you need to bear. You have a better response time, and the only trade-off is the accuracy might be somewhere close to 80, 85, or 90%. It will never be 100%. So, Manas, Sunil has a question. Do you provide any certification post this course? Can you answer that for me?
Yeah. I have already answered him on the chat. So yes, the answer is yes, we are providing.
Okay. Yeah. So, Sunil, since you are going to complete the projects, you will be provided with this certificate. Okay. So, Akshay says in industry we hear terms like business intelligence, data science, AI, and what is the scope in terms of switching career to one of those stream. So, Akshay, do you mean that you want to switch from one of those to another one, or you mean to say you want to switch from where you are right now? So if I ask, okay, you want to switch to them from where you are right now. So I think, Akshay, I will need to understand your background right now. But what we are going to cover here is the very basic course and the very starter course, wherein when we are going through the puzzle, I think you can understand that it is a very basic level course wherein the prerequisite is not there. It's kind of null. So it will be very easy to kind of capture the things here. In terms of switching the career, I would say you need to keep trying. Once you are done with this course, I think you can use LinkedIn to highlight this expertise. And right now, the pace at which hiring is happening in this area, I think it should be very easy for you to switch, because for them, for the employers, being able to find data scientists, there is a huge scarcity in the market right now. Any other questions I can answer? Manas, I think we can conclude the session as I don't see any incoming questions from.
Yeah, Vinay. So thanks, Vinay, for this valuable session, and I would really thank all of the participants who have joined, and the audience is from throughout the globe, as of course India and Germany, UAE, and Australia as well. So I hope you all had a great session to have the very base knowledge on machine learning with Python. Henceforth, I have shared the feedback link in the chat window to have your feedback so that we could really improve ourselves, or any kind of feedback, anything you give, it would really be helpful for us. And after the session is closed, we will share the complete recorded session as a video file with your registered email ID. So thanks again, and we're hopeful to see you in our upcoming the workshop session happening on 27th of this month. You can see the link, whatever winner shared just now on the screen. And we're hopeful to serve with a detailed session on the same course to have any of your doubts clarified. Thank you so much. Have a nice time ahead.